All right, let's look at the distance between lines. All right, so let's say you have two lines. We can probably call it L1 and L2. Actually, I'm gonna call this one L1 and this one is L2. All right, then it'll be defined to find the two closest points, and that's the distance between them. And we notice that this distance here and the angle is going to make a 90 degrees with both lines, because otherwise we can actually get even closer. All right, so in order to find that distance d, what we can do is we're gonna find 2 points. So I'm gonna put maybe P here and some random points. Oops, hold on. All right, random points P and Q. All right, then you think of a vector, and of course, vector PQ wouldn't have the length, but what we can do is we can project it onto the direction perpendicular to both V1 and also V2, right? So what we can do is we find that, but we know how to find it. So we want the direction vector going in this direction. So let's see, I'm going to use this color, right? So this direction right here, right? But we can achieve that by doing the cross product between V1 and the V2. So make it a vector here. All right. So then we want the unit direction. So what we're going to do is just to divide through by. So u, I'm going to let u to v. Just take the cross product between v1 and the v2. Then we divide it through by its own magnitude. Right? Oh, not addition. Cross product and v2. Right? Then since it's a projection, the distance d can be found by simply PQ, magnitude of vector PQ, times the cosine of theta in between. Right? Then again, we can do the same thing as maybe take the absolute value. And the absolute value of, we can actually squeeze in absolute value of u, because it's a unit length, it's 1 anyway. So we can again write it as this is just dot product. So PQ dotted with u. Right? So that's how you find the distance d. Right? So let's look at this example right here. All right. So we have two equations of lines. And we know that this is going to be, it's a point, so it's going to be P. And then this is going to be V1. And this is going to be Q. And this is going to be V2. Right? All right, so let's find vector PQ first. Vector PQ. Alright, so PQ, so 4 minus 4 is 0, negative 1 minus 3 is negative 4, and 1 minus negative 1 is going to be 2. Right? So this is vector PQ. Right? Then what we can do is we can find the vector u by first we have to take the cross product. So cross product between V1 and V2 would be, all right, so I, J, K, and let's see, we have V1 is 1, 1, 1, V2 would be 1, negative 2, negative 1, so this is going to be, all right, so it's it's a determinant of 1, 1, negative 2, negative 1, negative determinant of 1, 1, 1, negative 1, and determinant of 1, 1, 1, negative 2. Alright, so this is going to be negative 1 minus plus 2, so it's going to be 1. And let's see, negative 1 minus 1, so negative 2, so it's positive 2. Negative 2 minus 1, so it's negative 3. Right? So u is going to be just the same thing, but we just need to divide by its length. So it's a square root of 1 squared is 1, 2 squared is 4, negative 3 squared would be 9. So it's 1 comma 2 comma negative 3 square root of 14. Right? Then we just have to take the dot product. So D is going to be absolute value of, right, PQ is 0 comma negative 4 comma 2. Dot product with u, so it's 1, 2, negative 3 square root of 14. Right, so this is going to be that's 0, negative 8, and that's minus 6 over square root of 14. So it's going to be negative 14, but absolute value 14 divided by 14 is square root of 14. Right, so that's the distance between two lines. Right, so all you really have to do is take any point, 1 point from each line, and then create a vector, and then project it onto the cross product between the direction vectors. Right, that's it. I hope that this was clear.